Hello. Yes, then we come to this question. It says that consider the equilibrium below. This is the equilibrium we are talking about. And they say the amount of ammonia was decreased. Then the statement says that use Lecheteria's principle to predict the change in concentration of nitrogen, hydrogen. They say write increase, decrease, or remain the same. How do we approach this one? The best approach is to rewrite the equilibrium, the equation. It is nitrogen, which is reacting with hydrogen to give you ammonia. Okay? And we need to know that it is ammonia which is being withdrawn, which is decreasing. Now, you need to know that according to Lecheteria, this system does not want to be disturbed. So when you withdraw ammonia, the system forms it. And you need to know that formation of ammonia requires nitrogen and hydrogen to react. So they are decreasing. So that ammonia, which is withdrawn, is less stored. So let us see. The answers are already there. What are our answers? They are here. So what are we going to say? Nitrogen, answer is decrease. Hydrogen, the answer is decrease. Like I always tell you, please work out this. You don't need to cram it. Just make sure that you have the mechanism of working it out. Yeah, then comes this question. It says, state what happens to 1. Position of equilibrium, equilibrium constant, and rate of reaction. They say rate increase, decrease, or remain the same. Okay, to answer this one, we use Lecheteria. So what do we have? You rewrite the equilibrium. So that's what we have. And what do we do? We find out what happened. Ammonia was withdrawn. So I want you to tell you that when you withdraw ammonia, you are disturbing the equilibrium. And according to Lecheteria, the equilibrium should not be disturbed. So what happens? You remove ammonia, the equilibrium forms it. And how is formation of ammonia happening? By nitrogen and hydrogen reacting. The reacting of these two makes them to decrease so that this one can be restored. So I want you to know that position of equilibrium is from low to high. So this is what we see. And what is it? Forward is favored. So that's the answer. Forward reaction is favored. Okay. Then comes this one, equilibrium constant. Okay. The equilibrium constant is only affected by change in temperature. So anything which is not temperature has no influence here. So what's the answer? The answer is remains the same. Then we come to this last one. Rate of reaction. You withdraw ammonia, you reduced ammonia, so what happens to the rate of reaction? I need to tell you that any decrease, whether it's of a product or reactant, but if you decrease anything here, the rate of reaction will decrease. We are decreasing ammonia, so it will decrease. And I need also to remind you that any increase, whether of a reactant or product, it will increase rate. That must be noted. So, back to the question. We are decreasing ammonia, so rate will decrease. So the answer is decrease. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Don't forget to subscribe, to like, to share, to comment. And we need also to remind you that PSSB, Physical Sciences Silver Bullet, deals with physical sciences, grade 12, 11 and 10, and natural sciences, grade 8 and 9. Very perfectly. And about the use of this channel has a very wide scope. So, when you go to the channel, don't go to video. Just go to playlist. And when you reach the playlist, then you sort out material of your level. For grade 8, just press grade 8 natural sciences or grade 9 natural sciences. Grade 11 and 10, just press grade 11 or grade 10 physical sciences. For grade 12, every topic is a tile, and we believe that we have presented every topic very well. So make use of the videos, the lessons, the worked examples. Everything will be there. Don't hesitate. See you next time. Bye bye.